Hello students, this is lesson U4A04b. By the end of the lesson, you should be able to say, I can use properties of sides and diagonals to identify a rhombus or a square on a coordinate plane. So here are the properties, once again, associated with rhombuses, but we are going to be scrutinizing this under the lens of a coordinate proof. So how do we show, for the first property, that a quadrilateral is a rhombus via all four sides are congruent? Well, in order for us to show congruent lengths in a coordinate proof, we need to use the distance formula or Pythagorean theorem, or counting, or whichever method you can to find the length of something, okay? And we need to use the distance formula actually 4 times to find out the side lengths of all 4 sides. Moving on, the second property to find, or the second property used to show that a quadrilateral is a rhombus, is to show that the diagonals are perpendicular bisectors of one another. So in order for us to determine that the diagonals are indeed perpendicular bisectors of one another, we need to find the slopes of the two diagonals. We find a slope using the slope formula, and we need to show that the slopes of the diagonals are in fact negative reciprocals of one another. And how do we show whether or not that they actually bisect one another? Well, that is done by finding the midpoint between both diagonals, where we need to apply the midpoint formula twice. Moving on. So in this property here, much like with the property of for parallelograms where opposite angles are congruent, you do not need to worry about this, because in order for students to accomplish this, you would have to know trigonometry, and this is really just outside the scope of this course, so do not worry about this. The other shape that we have to look at is a square. So in a square, we notice that that all 4 sides are congruent, but not only are all 4 sides congruent, we have one angle forms a 90 degree. So how do we show that all four sides are congruent where we only have one adjacent side having 90 degrees? Well, we take the distance formula and we need to apply it 4 times, and then we're going to find the slope between one pair of adjacent sides. If we can find the slope of one pair of adjacent sides having negative reciprocal slopes, that would be enough to show that this is in fact a square. How do we show that a quadrilateral is in fact a square? By using the second property. If the diagonals are congruent and they are perpendicular bisectors of one another. So to do this, we need to use the distance formula to show that the diagonals are in fact the same length, and we need to apply the slope formula to show that the diagonals have negative reciprocal slopes, and then lastly apply the midpoint formula to show that the diagonals share the same midpoint. Again, for this property, you do not need to worry about, because we're really dealing with a problem involving trigonometry, so don't worry about this property. Anytime when we're dealing with some angle measure other than 90 degrees, do not worry about it, especially in particular in a coordinate proof. And then last but not least, we need to show that we're dealing with a rectangle with sides congruent, right? So the best way to approach this, okay, we apply use the distance formula to show that the diagonals are the same length, and we find the side lengths of all 4 sides having the same length as well. So I encourage you to, again, just take a close look, careful look at this slide and at this slide, as these contain all the properties that we need for this lesson. All right, so let's take a look. We need to show why is SAND a rhombus, and the way in which we're going to do this, you should definitely have graph paper handy. if you don't. So we're going to plot this out on a grid. And the way in which we're going to show this is we're going to find out the distances. Pause the video, see if you can figure this out on your own, and then we'll get back together. Hopefully you had some time to think about this. We're going to find out that this is in fact a rhombus by finding the side lengths of all four sides. So the side length of SA turns out to be 5. The side length of AN is also 5. ND is again 5. And SD is again 5. The declaration statement that you have to write is, since segments SA, AN, ND, and SD all have the same length, SAND is in fact a rhombus because all sides of a rhombus are congruent. We're going to show why SAND is a rhombus using another method. So what method are we going to use? We're going to try to approach this through the use of midpoints and perpendicular slopes. We're going to show that the diagonals are perpendicular bisectors of one another. So pause the video, see if you can figure this out on your own, and we'll get back together. So the slope of AD can be found to be -½ The slope of SN can be found to be +2. The midpoint of AD can be found to be 3, as well as the midpoint of SN can also be found to be 3, We again need to write a declaration that this is in fact a parallelogram, and what's the reason for this? Well, that's because since the slope of SN and AD are negative reciprocals of one another, SN and AD are perpendicular with one another. And since SN and AD share the same midpoint, SN and AD are also bisecting one another. SAND is a rhombus because diagonals are perpendicular bisectors of one another. Let's take a look at why ANTS is a square. Let's again plot this out on a grid, and the way in which you're going to do this is show that all sides are congruent and there is at least one right angle. Pause the video to see if you can figure this out on your own. And welcome back. So let's find out what are the side lengths of AN, NT, TS, and AS. So AN turns out to be radical 13. NT turns out to be also radical 13. TS, also radical 13. And AS, also radical 13. But that's not enough to show that this is a square, because this, after all, just demonstrates that it's a rhombus, because all four sides are the same length. We, again, need to figure out that there is at least one right angle. So in order to accomplish this, you can pick any pair of adjacent sides. So I chose AN and AS. You could have chosen another pair of sides, but the point is they cannot be opposing sides. They have to be sides that are next to one another. Okay, so the slope of AN, as it turns out, is in fact 2/3. The slope of AS is -3/2. This is enough information for us to demonstrate that ANTS is in fact a square, because since SAAN, NT, and ST are the same length, and sides SA and AN have negative reciprocal slopes, then ANTS is a square, because all sides are congruent and there is at least one right angle. Let's solve this again using another method. So for this method, I want you to approach this by showing that the diagonals are congruent and are perpendicular bisectors of each other. Pause the video to see if you can accomplish this. So we can show that ANTS is again a square by finding the lengths of the diagonals to show that they have the same length. So the length of the diagonal turns out to be square root of 26. Will they be bisecting one another? Will they be perpendicular to one another? Well, let's see. So the slope of AT turns out to be -1/5, and the slope of NS turns out to be +5, and that is enough information to show that the diagonals are in fact perpendicular. But are they perpendicular bisectors? So let's see. Will they have the same midpoint? So the midpoint for the diagonal AT turns out to be 7/2, comma 5 halves, or 3.5 comma 2.5. And then the midpoint for diagonal NS is, in fact, the same thing. So our declaration could be, since diagonals AT and NS have the same length, share the same midpoint, and have negative reciprocal slopes, then ANTS is a square because diagonals are congruent and are perpendicular bisectors of one another.